Okay, so we're going to talk about a geometric sequence. So a geometric sequence is a set of numbers where you take the previous term multiplied by a constant to get the next term. The geometric sequence is represented by an exponential function. It also is defined two ways. We have a recursive and then we have explicit. Okay, with a geometric sequence as well as an arithmetic sequence, remember the recursive is defined by the previous term, and the explicit is defined by the term number. Remember, if it's recursive, they have to tell you what a sub 1 is equal to, and it's just a sub n is equal to, remember a sub n is the nth term, it's going to be the previous term multiplied by r. R in this case is a common ratio. That's what you multiply by the previous term to get the next term. And then if it's explicit, it'll look like this. A sub n is equal to a sub 1, which is the first term, times r, which is a common ratio, raised to the n minus 1. And remember, n is a term number. Okay, so a geometric sequence will either diverge or converge. A geometric sequence will either diverge or converge. If a geometric sequence diverges, okay, then that means that the common ratio, which is r, must be greater than 1. Okay, now, when we talk about r being greater than 1, it's the absolute value of r, because regardless of whether r is positive or negative, if the number is greater than 1, it will diverge. For example, if r is negative 2, it would diverge because the absolute value of negative 2 is 2. If r was 4, it would diverge because the absolute value of 4 is 4. So it diverges if the absolute value of the common ratio is greater than 1. It converges if the absolute value of the common ratio is less than 1 but greater than 0. Okay, for example, if r is negative 1/2, well, the absolute value of negative 1/2 is 1/2, which is less than 1, so it'd be convergent. R is 1/3, it's less than 1, so it would converge. Now, an example of a geometric sequence. Now, in order to find out if a sequence is geometric, we do right divided by left. We do right divided by left. For example, if you had this as a sequence, okay, so I know it's a sequence, remember, because of the commas. I would do right divided by left. So 54 divided by 18, 18 divided by 6, 6 divided by 2, and I'm just checking to see if they're all the same. If they're all the same, then it's geometric. And then whatever that number is my common ratio r. So in this case, r is 3. So then my equation, remember your explicit equation is a sub n is equal to a sub 1, which is the first term, times r, the common ratio, raised to the n minus 1. So in this case, it would be a sub n is equal to 2, and then r is 3, raised to the n minus 1. That would be the explicit form. Remember, it's the explicit form because it's defined by the term number, but it also has the first term in it, the a sub 1. And then if I was going to write the recursive guy, a sub 1 would be equal to 2, and then my equation would be a sub n is equal to the previous term times whatever r is. Okay, now a geometric sequence requires a little more work when solving, so we'll go ahead and get into a couple of problems and talk about some different things here. So for example, if I had this guy here and I wanted the equation for this geometric sequence, I would do right divided by left, and I would see that they all give me the same number. They all give me 4. Okay, so that would be my R. So R would be 4, and then my a sub 1 is going to be my first term. So I'm able to write my equation as a sub n is equal to 3 parentheses 4 raised to the n minus 1. Okay, so that's how I would get my equation for the sequence. And then in addition to that, they could ask me some questions after I have my equation. So one question they could ask is, find the 7th term. Okay, when they ask me to find the 7th term, they're simply telling me that 7 is my n. So a sub 7, remember the subscript for the a tells you what term it is. So I'm looking for the 7th term, that's why I have a sub 7. And then I plug my 7 in there. So then in my calculator, I would just plug my information in. And I would get an answer. So my answer is 12,288. Okay, now another question they can ask me, and I'm just rewriting the equation here. Another question they can ask me which term has a particular value. So they say which term has a value of 786,432. So if they ask me which term has a value, then instead of giving me the n, which is the term number, they're giving me the a sub n. So what I would do is I would plug that into the formula. 786,432 is equal to 3 times 4 to the n minus 1. Then I would solve for n. I would divide by 3. And when I divide by 3, I get 262,144 is equal to 4 raised to the n minus 1. And then, because I'm trying to get rid of the base, I use log. I do log of that base to both sides. So I have log base 4 on both sides. Okay, and so to figure out log base 4 of 262,144, I go math to log base, and I type the 4 as the base, and then 262,144. Then I hit enter. So I see that my answer is 9. Now, if I had a TI-83 Plus and I wanted to do the same thing, I would simply just press the log button, which is the button next to 7, and then I would type in the inside number, close the parenthesis, and I would divide, and then I would choose log again, and I would tell it which base. Okay, notice you get the same answer. So in this case, I end up with 9 is equal to n minus 1. Therefore, n would have to be 10. N would have to be 10. Now, when we talk about a geometric, sequence, there are 3 instances where we have special stipulations. So, here's an example of one of them. So one of the stipulations is if you have a negative common ratio. So notice here I have a negative common ratio. I still would solve the same. I would divide both sides by 3 first, and I'm left with negative 2 raised to the n minus 1 is equal to negative 8. Now, if you have a negative common ratio, then whenever you solve, you're going to have to do log, and you're going to have to change the sign for the common ratio. Because remember, I can't take the log of a negative base, and I can't take the log of a negative number. So in this case, notice the common ratio is negative, as well as the what it's equal to is negative. So when I plug this in my calculator to solve, I'm going to do log base 2 on both sides. Okay, so I have log base 2 and it's showing negative 8, but when I plug it in my calculator, I'm going to do log base 2 of positive 8. I'm going to do log base 2 of positive 8. So in essence, I'm plugging in log base 2 of positive 8 in my calculator, and that's going to be equal to n minus 1. Remember, the negative common ratio, all that does is just tell me that I have alternating signs in my sequence. For example, you have 3, negative 6, 18, sorry, not 18, 12, negative 24. Okay, so that just tells you that you're going to have alternating signs in your sequence there. Now, log base 2 of 8 is 3, so I have 3 is equal to n minus 1, therefore n would have to be 4. So that's one instance. Notice you have your common ratio is negative and the number it's equal to is negative, so you have to change both sides. Then you have an instance where you have something like this. Okay, where you divide by 3 and you get 4 is equal to negative 2 raised to the n minus 1. Now, what you keep in mind here is that your common ratio is negative, but notice your common ratio is negative, but notice the guy to the right of the equal sign is positive. So the only sign I'm going to have to change is I'm going to have to change the base when I do log of both sides. So I do log base positive 2 of both sides, and so I end up with log base 2 of 4 is equal to n minus 1. Log base 2 of 4 is 2. So I have 2 is equal to n minus 1, therefore n is equal to 3. So notice if the common ratio is negative, then when I solve, I'm going to have to do log of the positive of the whatever the common ratio is. If the what it's equal to is negative, then I'm also going to have to change the sign. If there's no equal sign, then I leave it alone. In the last instance, just to make sure that everything is clear, is when I have something like this. I divide by 2 and I end up with negative 4 is equal to 2 to the n minus 1. Okay, in this case there's no change because the common ratio is not negative. Then I don't have to change any signs there. I don't have to change any signs there. Okay, and something I forgot to add to the arithmetic sequence video: an arithmetic sequence is a linear function. The function is a line. Wanted to add that in there. Okay, so this is the second video. The next video will be about series.